applications with our linear equations that we've been doing for this entire unit. So one of the big thing is when you're getting to your applications is you need to be able to identify what is your x and what is your y based on the context of your problem. Now within these problems, I would say 95% of the time it deals with some form of time, whether it be seconds, minutes, hours, years, months, days. Anytime they're dealing with a time, that is always your x. X is always a time. Y is usually the other thing. The other words we have used for these, and you have used them before, are input. Y is your output. And then there's one more set of words I'm going to throw at you. Your x's are your independent variable. Y is your dependent variable. Does anybody know why we would call them independent and dependent? One depends on the other. I can't figure out my y's unless I know what my x's is. And since x is generally time, independent also is you can't really control time. Time passes whether you want it to or not, so you can't really control it. All right, so let's take a look at our first problem here. We have Kirk is driving along a long road at a constant speed. He is driving directly towards Denver. He knows that after 2 hours, he is driving 272 miles from Denver. After 3.5 hours, he is 176 miles from Denver.
That makes no sense.
Makes plenty of sense. They're talking about the distance from Denver.
Yeah,
So
I know,
he first starts really far away from Denver. He's 272 miles. Then he drives some more, and now he's only 176 miles from Denver.
I thought you meant like, oh. Okay.
So that means he's getting closer and closer and closer to Denver.
I meant like further away.
Yeah. No. Did you have a question, Matt? Okay. So they want us to summarize the information given in the problem as two ordered pairs, where the number of hours is h, and your distance from Denver, they want you to represent as the letter D. So we're not actually using x and y. However, we are very used to using x and y. That's how we usually write our ordered pairs. But instead they want us to use an h and a d. So which one would be like my x, the h or the d? The h, because remember I told you x is always time. H they told us is number of hours. So h is like my x. I'm going to treat it like my x. Therefore, D is my y. So H is my independent, D is my dependent. Can't figure out my distance from Denver until I know how long we've been driving for. So when they say to summarize the given information as two ordered pairs, that means I'm going to take my first set of numbers, 2 hours and 272 miles. There's my first ordered pair. What would my second ordered pair look like? It's 3.5 hours, so 3.5, and we're how far from Denver? 176 miles from Denver. So there we go. We summarized our information into 2 data points. Part B, they want us to calculate the rate of change in Kirk's distance from Denver over time. So we know that phrase, rate of change, that tells me we need to use our slope formula. So remember, this is our x1, y1, because it comes from my first point. x2, y2, because it comes from my second point. So we're just going to use our slope formula. y2 minus y1 over x2 minus x1. Doesn't matter. If you put y1 first, then x1 has to be first on the bottom. So when we subtract the top, 176 minus 272, what do we get?
96.
And then 3.5 minus 2? So let's go ahead and divide those. What's negative 96 divided by 1.5? Oh, again. Say that for me again. Negative 64. So let's put that in context of the problem, because that seemed to be a little bit of a weakness on the test for you. It's negative 64 what? Now keep in mind, this is our y's over our x's. What did our y's represent? Miles. And then, yep, our time was hours. So this is negative 64 miles per hour. So if we took a look at part C, it says you should have found that the rate of change was negative. They want to know why is it. Explain what is physically happening to result in this negative rate of change. So why was our rate of change negative? Jordan? Because as he's driving, his distance from Denver is decreasing. So what is physically happening to result in the negative rate of change? He's getting closer and closer to Denver. So it's negative. We got to write a sentence here. Because his distance from Denver is decreasing. He's getting closer to Denver. Whenever you get something in your problem that tells you to explain, that means you've got to write sentences for it. So why is it negative? It's negative because his distance from Denver is decreasing. Explain what is physically happening. He's getting closer to Denver. So that answers our two parts. D, assume that the relationship is linear, which it would be since it's a constant speed. They told us at the beginning it was constant speed. Write an equation for the distance d as it relates to the number of hours h. So we have to write an equation, but instead of using mx plus b, we're going to use d for our y, h for our x. Remember, we wrote it up there above. They want us to use those letters. If they give you letters and you don't use them, you will lose points. You've got to use their letters when they're given. So, do we know our slope? Yeah, we already calculated. Our slope was negative 64. Do we know our b value? No, we got to find that. So I'm going to pick one of my 2 points. I'm going to use this point up here. I'm going to plug 272 in for my d, negative 64 in for my slope, 2 in for my hours. We have to calculate our b first. So negative 64 times 2, what do we get? Negative 128 plus b. So what do we do with our negative 128? Add it, perfect. What do we get when we add it? 400. So now we have our b value. We can write our equation. So it's going to be d equals negative 64h plus 400. What don't you like about that? Yeah. So you just got to keep in mind which one's your x, make sure you put that one in the x spot. Which one's your y, make sure you put that one in your y spot. You're just so used to x and y, but really we can use any letter. All right, next one's an example using a graph. A website sells MP3 downloads of music albums for $10 and Blu-ray discs for $30. Fiona wants to buy some albums and some movies. She plans to spend a total of $150. Write and graph an equation to represent the situation, and then state 2 combinations of albums and movies that she can buy. So for this one, we are going to want to use x and we are going to use y. And it doesn't matter which one we pick for it. So they talk about music albums first. So I'm going to say let x equal number of music albums. And my y will be number of Blu-ray discs. That's our two things that we're dealing with. And you need to state what your x and your y are first. I was going to say, I probably did. I am a horrible speller. But this time I was right. I have no idea.
It's like French spelling.
Well, then it would be B-L-E-U, wouldn't it? Yeah. It's been a few years since I've taken French, but yes. All right. So we'll write our equation. It's $10 for each music album, so 10x plus $30 for each Blu-ray disc, so 30y, and it's going to equal 150. So now with these types of graphs, it's going to be a lot easier for you to graph using your x and y intercept, because your slope's going to be some weird number. Your scale on your graph is not always going to be a nice scale, like these ones go up by ones, but sometimes your scale is going up by 10, 20, 30. So it's not always easy to graph your slope when your scale is different. So these kinds of problems, you want to calculate your x-intercept, calculate your y-intercept, and graph your line that way. So that's why we had our warm-up where we went over that today. So for x-intercept, what do I put 0 in for? Y. So 30 times 0 just gives me 0, so I'm left with 10x equals 150. So our x-intercept is 15. So for our y-intercept, I'm going to put 0 in for x. 10 times 0 plus 30y equals 150. So 30y equals 150. What does y equal? 5. On what? I'm going to get to that in a second. 1 second. So now when we go to graph, there's certain things you have to do to your graph before we actually graph. You need to label your graph. You don't want to be like Mrs. Pelkey, who got a 99 on her Algebra 1 Regents because I did not label my graph. Don't be that person. Label. So our x is number of music albums, so we have to label that. My x-axis is number of music albums. What is our y-axis? Number of Blu-ray discs. What is this whole graph talking about? We need a title for the whole graph. Isn't it like her purchases? Or you could call them downloads. We just got to make sure we give it a title. So now we can go ahead and graph. My x-intercept is going to be right on my x-axis. I'm going to put a 15 on my x, or a dot on my 15 on my x-axis. Y-axis, I'm going to put a dot at the 5. Then using your ruler so that your lines are nice and straight. Yes, you always have to write the equation on the line. Yeah. Now you got to make sure your line starts and stops on your dots. You cannot go beyond the dots on these graphs. You cannot put arrows on these graphs. You will get them marked wrong if you put arrows on them. Let's think about why. What happens if I go below my x-axis here? What is it saying? You won't go above your cost, but let's think about it. This is number of Blu-ray discs. If I'm below the x-axis, what are my numbers? Negative. Can I have negative number of Blu-ray discs that I download? No. So it can't go back that way. Why can't we be over here in this part of the graph? Because then that would be negative music albums. You cannot have that. So your graph cannot go beyond those 2 points. Does that make sense?
Yeah.
Okay. I think we got one more. All right, so Maria charges $15 for every 2 hours that she babysits. Answer the following questions based on this information. So A, how much would Maria charge for working 5 hours? There are several different ways we could figure out this answer. Who thinks they know one way that we could figure this out? Jordan? Okay, that's one way. So if we divide, what's 15 divided by 2? And now multiply that times 5. How much would she get? $37.50. Another way you could have done this is you could have set up a proportion of 15 over 2 equals x over 5, where you've got hours on the bottom, dollars on the top, and then you cross multiply. You would get the same exact answer. All right, so next they want us to fill out the table below for the amount that Maria makes as she babysits and graph the relationship on the grid provided. Yeah? So this would be 30, 45, 60, 75, 90. So then go ahead and plot those points on the graph below. This graph would have an arrow on just one of the sides because it could keep going. She could babysit longer than 12 hours. Could she babysit less than 0 hours though? No, so that's why there's no arrow over here at the 0. That's just a dot. They also didn't say this is 12 hours in a row. She could have just been 12 hours this week. Yep, there's no arrow here because she can't work less than 0 hours. But there's an arrow here because she could babysit for more than 12. So part C, they want us to write an equation for the amount A that Maria makes for the number of hours H that she babysits. Keep in mind that Maria will make $0 for babysitting 0 hours. So what are our 2 things we need to know? What's our slope? We already calculated up in the beginning. 7.5. What's our B? 0. It's at 0 on our graph. They also told us she makes 0 for babysitting for 0. So instead of y, they want us to use a. They put it over here on the graph. They told you there also, so instead of y equals, we're going to have a equals. Our slope is 7.5, and then h instead of our x. Now that we know our equation, you need to go and label your line. Always need to label. Then part D, use your equation to determine how many hours would she have to work in order to make $150. So what do I plug the 150 in for, A or H? A. A. Because you're looking for how many hours, and it also tells you $150. That's your amount. That is your A. So we would have 150 equals 7.5 H. Does everybody confer? So just a quick little sentence. She would have to work 20 hours.